Hello and welcome to week 8 of problem solving session for the NPTEL certification course on environmental impact assessment. This course is being taught by Dr. Harshit Soshan Lakra, who's an assistant professor at the Department of Architecture and Planning, Indian Institute of Technology, Roorkee. I am Isha Rathore, PMRF and Research Scholar at the Department of Architecture and Planning, Indian Institute of Technology, Roorkee. And I will be taking the problem solving sessions on Saturdays from 4 to 6 p.m. There is another problem solving session on Tuesday being taken by Ms. Monica S., another PMRF and research scholar from the Department of Architecture and Regional Planning, IIT Kharagpur. A few housekeeping rules. Please mute yourself for the session. If you have any questions, you can post them in the chat box. You can post the answers to the assignments, which we will discuss also in the chat box. I will keep moderating the chat box at different points to respond to your questions and answers. And if you have any questions, you can raise your hand and unmute yourself when I ask, when instigated by the instructor. Okay, so the general outline of the session is that we're going to talk about the highlights from each week. That is, we're going to look at the key takeaways from each of the lecture units for week 8 content. And we will also look up at assignment questions. We will also look up at assignment questions and their solutions to these questions with explanations. We'll also solve the week 8 assignment question because the deadline for the week 8 assignment has passed. So we will look up at the solutions to these assignment questions as well. And we will practice additional Q&A based on the previous one of the NPTEL course. And if there were any queries received during this week based on week 8's content, we will also cover them uh, in this session. Okay. Okay, moving on. So, week 8 is about impact management, mitigation, and preparation of environmental management plans or EMP. And we're going to look at the highlights from week 8. So, lecture 36 was on EIA methods, climate and climate change part 2. We have looked up at part 1 in week 7 review. So, in continuing from that, we looked up at the scoping and baseline studies for climate change mitigation. We looked up at the nationally determined contributions or the NDCs, which are the contributions that each signatory country of the Paris Agreement has assigned to reduce national emissions and adapt to impacts of climate change. So each country who has signed the Paris Agreement has given a sort of nationally determined contributions where they state that these are the national reductions in the national emissions which they are going to achieve by a particular year, and these are the following actions they will take for combating or mitigating climate change. So each country has defined nationally determined contributions as per the Paris Agreement. So, for example, commitments made in Europe to reduce carbon emissions by 80% by 2050. So, the European Union has said that they will be climate neutral by 2050. That is, they will have net zero greenhouse gas emissions uh, as their NDC. And we also have the similarly legally binding provisions in the UK under the Climate Change Act of 2008. So, this is the basis of the climate change frameworks which are existing across the world. And so there are four key questions for scoping as stated by IAIA and for determining the extent to which scoping needs to be done. So the first is the proposal. That is it directly or indirectly increasing or decreasing the greenhouse gas emissions? Second is the proposal beneficial or is it adversely affecting the vulnerable groups and causing climate change directly or indirectly. The third is that climate change may affect other aspects of the environment that are potentially affected by the impact of the proposal. And fourth is an objective of the proposal is to use impact assessment to identify alternatives and measures to mitigate and or to adapt climate change. So these are the four key questions which needs to be determined during the scoping for climate change mitigations for the projects to get environmental clearance. And So, in the preliminary scoping for greenhouse gas emissions reduction, as adapted from CEAA 2003. So these are checklist questions. So, for example, you can ask, is this project likely to generate significant volumes of greenhouse gas emissions during any phase of the project, be it construction, be it operation, be it decommissioning, post occupancy, all of in all of these stages, you determine whether greenhouse gases emissions are being significantly generated in the project. So illustrative examples of project that may prompt these questions are coal-fired generating plant. So this is uh, like a coal-fired generating plants which produce large greenhouse gas emissions. So they need to answer this question and see how to do climate change mitigation because they will be generating a larger amount of greenhouse gas emissions. And similarly, other large scale industrial manufacturing projects will also require this question to be asked and further steps being taken to mitigate the effects which they are causing to these various stages of the project. And then you can also ask questions around carbon sinks, whether that is the project construction or lifetime operation is going to adversely affect areas that we serve as carbon sinks for greenhouse gas emissions. So carbon sinks are basically areas or uh, areas or areas like forests, crops, peatlands, and wetlands which absorb these greenhouse gas emissions. So, large scale deforestation or flooding of land or changes in land use are projects or project components like these are going to cause a reduction in carbon sinks, which is ultimately going to increase the carbon being present in the environment if you destroy a carbon sink. So, again, projects need to ask if they are affecting the carbon sinks. And in another baseline study for climate change mitigation, we have the COP26, which is the Conference of Parties under the Paris Agreement. And as per India's commitment, the Indian Prime Minister Narendra Modi declared a five-fold strategy, which was termed as Panchamrit, to achieve net zero emissions. And there are 5 points in this strategy. So the first is that India will get its non-fossil energy generating capacity to 500 gigawatts by 2030. The second is that India will meet 50% of its energy requirements from renewable energy by 2030. India will also reduce the total projected carbon emissions by 1 billion tons from now onwards till 2030. And by 2030, India will also reduce the carbon intensity of its economy by less than 45%. And India will achieve the target of net zero by the year 2070. So this is the India's target to achieve uh, net zero emissions by 2070. And this declaration is termed as Panchamrit because we have a fivefold. This is a fivefold strategy to achieve net zero emissions for India. And then you also need, in the scoping and baselines, we also looked up at scoping for adaptation. So, scoping for adaptation, you need to look up at the agreement with key stakeholders or to come to a most appropriate climate change projection so as to adopt that assessment and to work towards the mitigation effects and to look up at what considerations can be taken to reduce these to adapt to these uh, climate change projections and to identify the scale and scope of the project's initial design and its potential impact on the receiving environment, taking into account how this will be affected by a changing climate where the temperatures are increasing, the extreme events are happening more frequently. So you need to look up at all of those aspects. And then you also need to engage with key stakeholders to identify policy and regulatory frameworks regarding climate change in the area in which the development or the project is coming up. So these are considerations for scoping for adaptation. And then certain issues need to be considered when we are scoping for adaptations. And these are basically the regulations and legislative requirements which are applicable to that particular project site. You also need to look up at the nature of the project and its location and the resilience to climate change that the project has. You also need to look up at the duration of the project, whether it's a long-term project or it's a short-term project. And you also need to look up at the climate-related parameters which are likely to influence the project, any anticipated changes to these climatic parameters over the life of the project, that is the construction period as well as the uh, total project period, that is the lifetime of the building or the industry or the project. And you also need to look up at the sensitivity of the environments potentially affected by the project to these climate parameters. So these are issues which you need to identify during scoping for climate change. And then there are certain considerations when you identify base studies for climate change adaptation. You need to look up at the historical past climatic conditions of the area. You need to look up at the current conditions at the time of the environmental impact assessment. And you also need to look up at future climatic projections. So in the range of, say, 15 to 30 years, and in the longer term, for instances like 50 years and more, uh, or at least considering the lifetime of the project. For example, for buildings, the project is the building's lifetime is usually considered as 50 years. So you need to consider the entire 50 years for the longer term assessment of the project for climate change, because climate change events are occurring more frequently now. So these are also things which you need to consider for climate change adaptation during the scoping stage. And then you need to assess these climatic factors. These climatic factors, like extremes in short-term weather events, extremes in longer-term climate adaptability, changes in average climate norms, and then you also need to identify the vulnerability and sensitivity of receptors. So receptors are basically people who are going to receptors are basically like people, ecosystem, biodiversity, and all of these things. So anything which is on the receiving end of uh, any outcome or the action. So you have high vulnerability where these receptors are directly dependent on climatic conditions, for example, like if like crop production, things like that. Then moderate vulnerability where these are dependent on some climatic factors but not but are able to tolerate a range of these conditions. And low vulnerability is when climatic factors have little or no influence on these receptors. So you need to consider the vulnerability of the receptors through your projects in the climate change adaptation assessment. And then you also need to assess the impact of the project for climate change mitigation. That is, it generates energy. Uh, it generates energy by using fossil fuel, and it consumes, whether it consumes energy, whether it generates energy by using renewables, whether it's removing carbon, that is, it is using some sort of carbon capture and storage in its project, or it is protecting the carbon sink. So you need to look up at the mitigation side. That is what sort of activities the project can do so as to mitigate the adverse effects it is causing, which were identified during the scoping period, the scoping stage. So you can do put the like minimize the adversity of the impacts by mitigating them through the project itself. So you can use a few of these things to have sort of a climate change mitigation side to the project. And then we also looked up at impact prediction and evaluation, that is climate change impacts on the project and on the receptors. So we have sectorial assessments for climate change impacts. So based on different sectors, the climate change impacts are different. So the different sectors are agriculture and forestry, business, health and well-being, buildings, infrastructure, natural environment. So for all of these sectors, the climate change impacts are different. And so, for example, you identify the risks and opportunities of climate change for built environment and health and well-being. So these are just examples. So, for example, for built environment, especially particular to energy, we have the energy infrastructure at significant risk of flooding. There is a higher energy demand for cooling. There can be heat damage or disruption to energy infrastructure. There can be increased water demand for energy generation for during the project phase, and the opportunities to reduce this energy demand for heating. So you can use strategies to maximize these opportunities. And then similarly for built environments around transport, so for example, roads, railways, and tunnels are at significant risk of flooding because of climate change in a extreme event of flooding. And so the opportunity here is to have to reduce short and the other risk is the scouring of roads and rail bridges, which is caused by removal of sediments from around bridge abutments of piers, and the opportunity is to have shorter shipping routes and reduce transportation costs due to less Arctic ice. Similarly, for water, you also have the supply demand deficits and the opportunities to manage this supply demand deficit. So you need to identify the impacts and on the different sectors, and then you need to look up at opportunities to combat it so as to help the environment clearance process for the project. Similarly, for buildings, you have damage to property due to floodings and coastal erosion, overheatings in buildings and like homes, schools, and hospitals because of rising temperatures, or during a extreme heat wave event. The increasing impact from the urban heat island effect, the buildings being affected by subsidence. All of these things are risks which you need to identify particular to your project and then look up at things. Similarly, you have risks for health and well-being where these temperatures, rising summer temperatures can cause heat strokes, mortality risks. Then you also have for flooding, you have risks of death, injuries, people suffering from mental health issues. Increased ozone levels can cause risk of mortality and respiratory hospital admissions. The summer temperatures can also cause skin cancer or rashes or irritation to skin and things like that. Uh, then increased temperature and changing rainfall patterns can lead to health risks from water, vector, and flood-borne disease. So things like that are risks from climate change effects, and the opportunities are again to combat all of these things through effective design and measures in your project. So you can identify similar examples in your project as well. And then you also have the vulnerability assessment approach, which assesses the magnitudes of the impacts of the project on baseline conditions under current conditions and the significance of these impacts. And then you identify the effect of climate change on receptors without the project. And then you assess whether the impact of the project will be worse or improved on the future baseline. And then you define if these changes affect the significance of effects that are identified for the project without climate change. So you basically consider you define a baseline case that is at your current conditions, and you identify effects without the climate change aspect of it, and then you identify the effects of climate change without the project, and then you look up at the future baseline the effects which are going to happen, and then you determine whether these effects are more significant or whether your project is causing more significant effects or not. So that is vulnerability assessment approach. And then similarly, you have this interaction between climate change mitigation and adaptation. So you need to have like a consistent mitigation and adaptation approach in your project. So this was all which was covered in lecture 36 on climate and climate change. And then moving on to lecture 37, we had EIA methods for ecology, which are definitions and concepts. So first we look up at the definition. So ecology is the study of ecosystem, habitats, communities, and species. Ecosystem is a self-sustaining functional system consisting of physical, chemical, and biological attributes. Habitats are conditions needed to support a species or community of species in a particular location. Community of species in a habitats are groupings of different species that have evolved in ways that facilitate their coexistence and regularly and recognizably occur together. A biotype is the environment typically supporting a specific recognizable community, and this is also strictly defined as a biotope as well. So the study of ecosystems is ecology. Ecosystems is this entire network, the system of all of the physical attributes like the environment and the physical phenomena, the chemical things like the uh, nutrients, gases and things which help sustain the ecosystem, and the biological attributes, human beings, biodiversity, flora, fauna, all of these together is the ecosystem. Habitat is basically the conditions required for supporting the supporting the constituents of the biological constituents of the ecosystem, which is the conditions required for supporting human beings is water, air, uh, and things like that. So particular habitat conditions are a habitat is basically uh, the conditions for support for any species or uh, the any species in a particular location. And communities of species in the habitats are basically different species coexisting together in a particular habitat. Biotype is basically environment which is supporting specific recognizable communities, which you find only in that type of environment. So, ecological impacts assessment is the process of identifying, quantifying, and evaluating the potential impacts of defined actions on ecosystems or their components, and provides a scientifically defensible approach to ecosystem management. This was the definition given by Trivik in 1999. So, just a tip definitions are important from an examination point of view as well as for your understanding. So, you should definitely look up at the different definitions in the different modules. Then we also have the ecological receptors, which are the ecosystem, species population, individual species, ecological features, unique landscapes, areas of habitat essential to the structure and function of ecosystem associated with the proposed development. And so the key factors of ecosystem are basically the main interaction that takes place between the components and the process. That is the vegetation. For example, the vegetation cover is related to soil, which is related to the which is related for the sustenance of bacteria and fungi in the soil. And again, these are connected to each other by maintaining the quality of soil and the cover of the green cover and things like that. So all of these interactions are significant factors for ecosystem and critical factors are that. And then we looked up at the simple model of interaction between the subsystems of a terrestrial ecosystem. So this is again based on the interaction between the different components of the ecosystem with each other. So community includes plants, animals, and microbes all together uh, for the terrestrial ecosystem. And then you have the soil and geology, which is responsible for supporting the microbes. Then you have the geomorphology, the atmosphere and climate, the hydrology, all of these together contributing towards the sustenance of the entire ecosystem and the well-being of the ecosystem. So these are key factors of the ecosystem. Then we also looked up at the concept of ecosystem resilience in terms of stability, fragility or sensitivity, resilience or recoverability, and recreatability. So stability is the state in which changes over time are within the normal bounds of variation. That is, it is the ability of an ecosystem to resist environmental change. Then we also have negative feedbacks, which are feedbacks within the ecosystem that slow down a process. So these are feedbacks are which are responsible for slowing down the interactions in the ecosystem and causing delays. So and then inertia is a delay or time lag or slowness in the response of an ecosystem to a driver of change and in its recovery if the cause is removed. So inertia is any delay or disruption to the response of the ecosystem component to any change which is being inflicted on it. And when this change is removed, it recovers very quickly. And then fragility or sensitivity is the weakness to environmental pressures. So a fragile ecosystem is more easily altered and may lose its ability to recover from impact more easily than a stable ecosystem. So, and then resilience is the ability of an ecosystem to absorb disruptions without causing a threshold to a different, usually degraded state, in which case it is virtually synonymous with stability. Recoverability is the ability of an ecosystem to return to a pre-disturbance stage and the speed at which it can do so if the disturbance is removed. And recoverability is an important aspect for EIA, short-term impacts such as construction phase of a project. So when the construction activity is finished, the ecosystem of the site, the recoverability of the ecosystem of the site is an important factor which is assessed in EIA short-term impacts, especially for different phases of the project. And then recreatability is the potential for establishing an ecosystem of richness and complexity similar to the ecosystem that has been destroyed. We have then we also have the habitats. So habitats are basically species composition. So these are numbers and types of species in the landscape. They can be quantitative data on species abundance, that is the number of species present in a particular habitat, and the description of the dominant species, that is the species which is present in the largest number. Keystone species, which are we looked up at keystone species in the last lectures and indicator species. So we look up at habitats through the species composition and the numbers of these species and the types of these species in a particular habitat. And then we also look up at the vegetation structure or the physiognomy, which is the physical structures and features of vegetations which influence the behavior of wildlife populations. And so these are basically distinct characteristics, that is the types and proportions of plant life that form the physical matrix of vegetation types and the vertical structure. So you have triangular shaped trees and you have a large canopy-based trees. These are vegetation structures, examples of vegetation structures, and then species richness or diversity is a measure of the biodiversity. And this also looks up at the trophic structure of the ecosystem and the flows of energy and nutrients to communities and the ecosystem, the food chain, food web. All of these are critical aspects for determining the species richness or diversity. And then spatial pattern is the spatial configuration of communities, that is the plants, animals, and microbes. And then in habitats, we also look up at transition zones, or also known as ecotones. So these are zones between two adjacent communities, and these are often species rich because they contain species of adjacent communities. So these are basically when they occur basically when we have two or more species coming together. So these are basically at the boundaries of two ecosystems. So it has the characteristics of both the two ecosystems, and they are known as ecotones. And then we also look up at the temporal pattern, which is community changes through time. So short-term changes can be seasonal variation, year or drought or cold and things like that. And then also for geological succession, which is the progressive that culminates in the development of climate, which is a means of state. And then we moved on to the concept of us about the amount of sulfur dioxide present in the air. Uh, this is especially black spot farmer can tell us again about the sulfur dioxide in the air. Uh, Similarly, for water and things, we have there's a presence of large fly, caddis at each other. Uh, these species are the presence of these species indicate pollution, high pollution levels. So these are pollution indicator species. And then we also look up at the approach for baseline studies for species population. So we have the listing approach, the snapshot approach, and the dynamic baseline. And there are certain tasks which you need to undertake for doing a baseline study. That is, you need to identify species which can tolerate short-term environmental variations. And then you also have species which return to their prior stable state or settle into a new equilibrium supported by the altered environment. Also, you need to identify species which respond to these slow progressive environmental changes by evolving or changing their geographical settings. That is, they are quick to adapt to change or quick to adapt to climate change and urbanization and things like that. And then you identify specialists which are adapted to a narrow range of environmental conditions or food sources and are more vulnerable to environmental changes. And then you identify generalist species, which are species which have less foraging requirements. That is, they can exist in a lot of different conditions, whereas specialists only exist in particular conditions and adapt to species or species which adapt to these changes. So you identify all these different types of species for doing an ecological baseline study. And then during the scoping stage, you determine the study area, that is the impact area or the project affected area. You determine the survey methodologies which you are going to adopt for measuring and quantifying the uh, species and the other things. Then you also look up at the assessment methodologies and the key ecological issues to address, that is the inclusion and exclusion list. And we also looked up at the concept of valued ecosystem components, which are species, habitats, or sites that qualify in terms of their ecological or conservation value, or other such attributes in terms of, for example, socioeconomic value. So these are ecosystem components which have value from ecological or conservation point of view. So these can be species or habitats or sites. So these are identified as valued ecosystem components or VECs. And then in the scoping stage, you finalize the methods for surveys for each habitat and species. You finalize the sampling methodology, the numbers, timing, location of each survey to be undertaken. You finalize the methods, that is methods of ecological importance, methods im- uh, for calculating the magnitude and the impact significance. And then you also finalize the reporting requirements and the reporting mechanisms in the scoping stage itself. And then we looked up at terms of reference based on the different sectors. We looked up at the description of environment, what falls under ecological sensitive zones like national parks, wildlife sanctuaries, and things like that, wetlands. So these are again from the EIA notification of 2006 for India. And then we also looked up at lists of important components for AIA. So we looked up at baseline data generation. We looked up at the biological biological data, species composition of flora and fauna. For flora, you look up at different types, density, exploitation, etc. For fauna, again, you look up at distribution. So flora is plant uh, distribution, abundance, rarity, migratory species, diversity, habitat requirements, resilience of the habitat, economic significance, commercial values, and things like that. And for fisheries, you again look up at different species of fish, whether they are migratory or not, species which have commercial or recreational value, that is the fishing industry and the commercial fishes and things like that. So flora plant material and fauna is basically animals and animal species. And then we also look apart for doing desk-based studies and surveys. We also have different organizations which hold ecological data or which are archives of ecological data. As it's National Remote Agency or the NRSA. Hyderabad, we have the Forest Survey of India, and Dehradun, the Wildlife Institute of India, the World Wildlife Fund, WWF. We have the Zoological Survey of India, Botanical Survey of India, State Forest Department, State Fishery Department, State Agriculture Departments, universities, Ministry of Environment and Forest, MOEF. So these are organizations which have and hold data. So typically within the 7 kilometer radius of the sites, and also for other species, endangered species, aquatic species like that. So there are studies for determining your baseline. And then so for test studies, those like uh, the use of GIS mapping, human resources, ecological expertise, requirements of professionals, and things like that. And then for field work, you require very the timing of field work should basically consider the different variations because of seasonal climate, and for measuring the pattern of migratory species. So the field work should include timing such that these aspects are included, and they should start at least 1 year before the submission date of the EIA report study. So that an equal representation of the year is put into the data for the ecological side of the study. And then for initial baseline surveys, there are simple techniques like zoologists field walking on your site and just observing things, things and making a note of it mentally. You can also use recordings to just record the site and your movements. Then you can do thematic mapping or classification system. So these are simple techniques for initial surveys on site. And then you can use methods mapping of vegetation or habitat. So you have handheld electronic devices and GPS. You can use satellite imagery for looking at different species from the atmosphere. You can look up at aerial photography. You can use GIS. You can use the line intercept method. So in the line intercept method, we have parallel lines which are drawn on the map or on the aerial photographs. To estimate the spatial distance occupied by each habitat type along a survey transect. So you have parallel lines and you measure the different uh, at different points you measure what species are being encountered on that line. So this is a line intercept method, and then you measure the percentage of the site which is covered by each habitat type which falls on your line which you have drawn on your map or on your aerial photograph. So this is the line intercept method. And then we also have different techniques for wildlife. Again, I will not go into details for these techniques. If you are interested, you can read up on these techniques. So you have observation on presence of tracks, that is footmarks, and presence of prey on site. And then signs of feeding, that is bones or carcasses, resting or occupation areas, tunnels, hairs and feathers on the site, scratches or marks on vegetation and in the soil, scat, dung, and feces. So these are things which signify the presence of wildlife and different species present on the site. So this is again an initial things you can use for initial baseline survey. And then we have species abundant measures in which we measure the amount or the presence of a species, whether it is abundant or it is in low numbers. So you look up at the magnitude or the presence of that species. So these measures include semi-quantitative abundance ratings. We can also look up at the number of individuals per particular species. We can look up at the cover of a species, which is usually expressed as a percentage of the studied area. And we can also look up at the frequency of the species, the presence of that species in an area, which is usually also again expressed in terms of percentage of the studied area. So if we have to look at the descriptions of a semi-quantitative abundance ratings, we use a visual estimation system. So we have a system known as DAFOR. So D stands for dominant species, A stands for abundant species, stands for frequent species, O for occasional, and R for rare. So each of these prefix of the first word uh, forms DAFOR for each category. And so you basically on the site observe these species and then you quickly record the particular initial against each species. So you assign a category to each of these species based on your initial observation on site. So again, these can be subjectives and approximate, and they have a reduced potential for analysis and presentation, and they're generally more suited to initial studies rather than detailed studies. So this is something you just do as an initial study. And then the second measure was the number of individuals. So this is more suitable when you have less number of individuals on site on your study site. So you can easily count the number of individual members of a species. And but if you have a larger species, this cannot be applied because again these are larger numbers. You can't count all of these members in a short span of time. So in that case, we will go for a different measure. But if the number of members of a particular species low, you can use measures. Again, there can be two counting measures. So these can be direct counting or they can be indirect counting methods. So indirect counting, you just directly count. So this is applicable for plants like stationary things or mere sedentary animals who are not very active, or for small population of animals within defined areas. Occasionally, whole populations, that is trees and nesting birds, can be counted in smaller areas. But if and these are usually done in samples like in quadrants or plotless sampling. Whereas for indirect counting methods, this is used for fairly smaller populations and for species which are fundamentally more active. So you use a method which is known as capture, mark, recapture. So you basically capture the members of a species and you mark them or put a ear tag or some sort of marking strategy. And then you again release them on site. And then you resample this population again after a suitable amount of time to see if the numbers have increased or not. So there are two methods of counting the number of individuals, direct and indirect, and indirect includes this capture, mark, recapture method. And then, so for cover, the other method is cover. So you basically look at the percentage of ground which is occupied by different species, and this is measured in terms of quadrants. So you divide your study site into four quadrants uh, by a visual line or vertical projections, whichever is necessary. And then you can use alternative methods like line intercept methods or point coordinate and things like that. And you can do these cover-based studies are usually for species which have different sizes. So, and because visual estimates are prone to observer error, these methods can be used for uh, large scale studies and for if your project site is very large and you have more number of species and for increasing the accuracy of your assessments, you can use cover based measure, which is more accurate than the other two studies. And then the and frequencies again, so you take different samples from the site and then you see if that species present in that site or not. So this is the frequency based percentages, and there are a few limitations to this study as well. So it tends to overrepresent small species. That is, if you pick up the sample from a site and you have a smaller species coming in that particular sample and you collected a few number of samples and you picked up the only sample which had the smaller species, so you get there's a risk of over representing this less frequent species in your study. And then again it also depends on the quadrant size, and it is a bit time consuming as well. So these are certain limitations to the frequency measure. And then for detailed surveys and evaluation of baseline studies, so there are two purposes to doing a detailed ecological survey. The first is to supplement the findings of any preliminary survey and desk-based studies, which often lack this quantitative site-based real data, and then to collect enough quantitative information to create baseline information. So this is the purpose of doing a detailed ecological survey. And then for data collections, you have methods like plot sampling, where you use quadrants to collect data. Then you have plotless sampling, where you use methods like transit walking and the use of line intercept methods, or measuring distance measurements from sampling points, or a combination of habitat and activity surveys. So these are plotless sampling, where you do not divide your plot into further subplots. And then you also have specialized collecting equipment, where you can just use your equipment to collect data on different species. And then these survey methodologies, specifications at planning stage are different. So you have temporal sampling patterns. You also have to look up at the sample size and the percentage of areas, the target or your study area. So you can't study the entire site area if it's a very large site. So you can identify a percentage of the site area as your target area for doing your survey. So these are again things which you need to consider in your data collection methods. What type of method you need to go and what type of survey methodology you're going to adopt. And then, so there are detailed surveys and evaluations of these surveys. So for plant surveys, you can use simple line transect methods or spatial sampling patterns. Then for fishes, you can use netting, enclosure traps, angling, and things like that. Fish traps or fish passes. You can use gill nets and fight nets. Again, these are techniques which you can read up more on if you're interested. But these are some of the techniques for different, we look up at different animal and plant species for doing their surveys. So you can read up more on them if you're interested. And then for amphibians like frogs, you can do survey at the breeding sites or ponds, swamps, or slow flowing rivers, and especially around the site during the breeding season for these species. And then the main methods which are used are pond netting, torching at night, bottle trapping, and searching for frog and toad eggs during the breeding season. Then for reptiles, you have methods of trapping. So you do pitfall traps for smaller species, and then you do transect walking for larger species. For larger species, you also have this direct observation, and you also have the capture mark release technique, because you can't uh, keep them in the traps for longer, and you have to have larger traps for larger um reptile for larger species. So you just capture them, release them, capture another one, release again, and so on. So, and for birds, we record their presence in terms of their species, their size of population, their vulnerability to potential impact. We also look up at their breeding surveys, transient surveys, transit walking. The other techniques include flight line surveys, radio tracking, collision mortality monitoring, and things like that. For mammals, so we have three groups of mammals. We have bats, small mammals, and large mammals. So for bats, we have direct observations or ultrasonic detectors. So bats produce this ultrasonic frequency. So you can use ultrasonic detectors for these species using the echolocation phenomena. Then you can use endoscopes or photographic cameras. You can use flight pathways, detection by staining, then dropping it means. You can use techniques includes tracks, nest tubes, light trapping, marking capture, optical and infrared photography using sensor activated equipment, things like that. And then for larger mammals, you can do direct observations using field signs and survey methods, or you can use radio tracking for larger mammal species. For terrestrial invertebrates, you can do observer independent and observer dependent methods. So observer dependent methods include direct searching, recording, transit walking, sweep netting, soil samples. Observer independent methods includes pitfall traps, light traps, water traps, and other things. You can read more of them if you're interested. And then for detailed surveys on habitats, we have three different types of habitat categories. So we have the modified habitat, which is a habitat that supports a community which contains a larger proportion of non-native or introduced fauna and flora. That is, these habitats do not just have the natural species, but they also have foreign or invasive species in their composition, and where human activities have modified the area have identified the area's primary ecological function. These are areas which include agriculture, parks, amenity areas, commercial, forestry, and plantations, reclaimed or modified wetlands and rivers. So these are areas which have been modified by human interventions. That is, they wanted to grow a different type of crop to meet up the country's food demand. So they bought in different types of crops. They grow different types of crops which are not native to that particular habitat. Similarly, for parks or for larger developments where you bring in foreign species or plant species which look more attractive. So that is a modified habitat. And then natural habitat is an area which is composed of viable assemblages of plant and or animal species of largely native origin, and where human activities have not essentially modified an area's primary ecological functions and species composition. So these are areas which have not seen human activity affecting the ecological function of the habitat. And then we have critical habitats, which are key habitats in maintaining the global biodiversity. So these include sites which have high biodiversity values. That is, these sites are habitat to critically endangered or endangered species, or endemic or restricted range species, and they have significant concentration of migratory birds or congregatory species for part of the year, or they contain unique or highly threatened ecosystem, or these are areas which are associated with key evolutionary processes. So those are critical habitats. And then we also need to look up at environmental variables and site history in our detailed ecological surveys. So we look up at environmental factors like the topography and the aspect of the site, the local climate information, the soil conditions, water quality, the geomorphology, pollution levels, existing and historic land, habitat, and site management. And then you also look up at the site history, that is, you document the past conditions, the historical and archaeological information, the evidence on ecological conditions using ecological techniques. So you document the environmental factors on the site and the site history, the different number of parameters. And then you identify changes without the development. That is, you need to compare the ecological impacts of a process, which considers the biodiversity may occur in its absence. That is, changes in the environment if the project was not implemented. So you need to document those without the development. And then this description should include the aim and scope of the investigation, a description of the ecological surveys which was undertaken, the detailed field surveys which were undertaken, the weather conditions, findings of the initial survey, the provenance and age of the data collected, clear representation of the results of the work, evaluations of all key receptors, assessments of the environmental factors, site data, information on current land use, and indicators of limitations. So these are a description of all of these factors should be in your ecological summary. And then we move on to lecture 39, which talked about the EIA methods for ecology, impact prediction and evaluation. So we looked up at the impact on ecology. So we had the IFC Performance Standard 6, which is the PS6 on biodiversity. And it says that the ecology assessment should include direct impacts, indirect impacts, residual impacts, and cumulative impacts. So direct impacts are things which cause an action which directly impacts the environmental parameter or the ecology. Indirect impact are an action causing another impact, but that impact causes an indirect impact on to the ecology. And the residual impact is the result of an action being undertaken, causing to a particular impact, but it's not a direct impact. And then cumulative impacts are when two or more impacts happen together because of an action. So that is a cumulative impact. So direct impacts include habitat loss, disturbance, emissions to the air, land and water pollution, alteration of surface hydrology and landforms, edge effects, forest gaps, loss of provisioning ecosystem services, degradation of regulating cultural and sporting ecosystem services. Whereas indirect impacts include accidental introduction and spread of invasive species, project-induced access by third parties, in migration and associated impacts on resource use and other things. And so you also need to identify the type of ecological impact. So it can be a temporary or a pulse impact, or it can be a sustained or a press impact, or it can be a catastrophic or highly destructive or irreversible impact. So these are the type of ecological impacts. And then you also need to identify the significance of habitat destruction. So this is when the ecological or conservation value and species dependency is being impacted, or the presence of a rare, protected, or notable species within the habitat is lost. So that is when you can classify a habitat as habitat destruction. When the degree of displaced species migrate and survive in suitable sites or habitat patches, the quantity of habitat is lost, or there's fragmentation which is happening, or the integrity is not retained in a habitat. So these are things you need to identify and look for through your project, whether it is causing a habitat destruction at any stage of the project because of the actions being undertaken for the project and its components. And then we also look at the obstructions or blockage which are created between the habitats. So these can be physical, for example, preventing wildfire from crossing a site. Then you have things like boundary, roads, rails, canals, pipelines, and power lines. So these can cause a physical disruption to the habitat by causing fragmentation. If you have a road which divides the site into two parts, so that is a habitat fragmentation. Then you also have behavioral obstructions like creating an environmental condition that wildlife is unwilling to enter. Again, when you put a road between a habitat, the animals will not have free movement in that habitat animal, and they will have to cross a road. So this is something which happens when you have highway projects and things which pass through a wildlife area. So you have a lot of uh, animals movement being restricted, a loss of biodiversity and species because of the accidents which are caused when vehicles hit these animals. So these behavioral obstruction, and these barriers can also be hazardous to the habitat and the habitat integrity. And then things like edge effect. So we have when you create an edge, you basically affect the uh, uh, so the edge is not as ecologically balanced as the rest of the ecosystem. So the edges are basically if two ecosystems come together on an edge, we have an ecozone, which is two or more ecosystems existing together. So for example, we have a deciduous forest species ecosystem on this side, and then we have a grassland ecosystem on this side. And then this area where both of these ecosystems come together is the grassland forest ecotone. That is the characteristics of both the deciduous forest ecosystem and the grassland ecosystem can be observed in this area. So this is a natural example of an edge. So this is an ecotone where two or more ecosystem coexist. So you have species from the forest ecosystem, and then you have the characteristics of the grassland ecosystem, both in this ecotone region being present. But we also see that the edges are not as fundamentally equally balanced as the rest of the ecosystem. This is something which is known as the edge effect. And as we increase as the edge decreases, that is, if the total area of the edge increases, the loss of uh, the ecosystem gets reduced. So the further fragmentation of an ecosystem will lead to more more destruction to the ecosystem diversity. So this is the edge effect. Then we also looked up at the effects of habitat isolation. So this is the species dispersal capabilities, the nature of land use between the habitat patches, the degree of isolation between habitat patches, and the distance and severity of barriers between them. We also looked up at habitat fragmentation, which is again a larger habitat being fragmented into two or more segments because of a human induced action. And so this again leads to the edge effect, which is so this creates an additional boundary. So we have a loss of this much amount of ecosystem from this particular case. So we see a large number of habitat being disrupted because of the habitat fragmentation and the edge effect coming into play. And then we also looked up at the significance of barriers, which varies between the species. So some species have efficient dispersal mechanisms, that is, they are not seriously affected by most local barriers, whereas some species are more very limited, have very limited dispersal ability, and they have and these are restricted to remaining habitat patches, or they are unlikely to recolonize these isolated habitat patches. So again, species can be both adjusting to this fragmentation and barriers, whereas some species will not be able to adapt and fragmentations and will further cause their numbers to decrease. So this is a significant impact on ecology for these type of species. And then we looked up at the cause of habitat damage through vegetation trampling or the plant damage or removal and soil compaction or erosion. And this mainly occurs during the construction phase of the project where we remove a lot of soil for construction of foundings and footings, the footings and things. So you remove a large amount of soil from the site and you disrupt the natural soil habitat. And then we also have the traffic and recreation of visitor pressure, the increased hunting pressure, and the destruction of microhabitats on site. So especially in the construction phase of the project, the habitat assessment will be done. And then we also have cause of wildlife disturbances. This is again caused by construction, traffic, or visitor pressures, and this can involve a number of factors, which include like visual impacts, noise, trampling, and nighttime light pollution, which causes these species to further move inwards in the forest area, and significantly the result in them not using a part of the which was earlier their habitat. And the susceptibility of animals to disturbance often also varies seasonally. Uh, okay. And then we also look up at impact of changes in the hydrological system and the climate. So we looked up at soil droughts, the loss of wetland and habitat, increase in water levels, incidence and duration of inundation, waterlogging of floodplains, damage to temporary water habitats. The change in water flow can change its property with respect to oxygen concentration, nutrients, sediments, and volume. So these are impacts to the hydrological system and climate. And then we look up at the methods of prediction of impacts or measuring of impacts for flora and fauna. So we have a sample plot method where we take different samples from a plot of land. So we use random sampling plots at the site, and we select different plots and we take samples on these plots. And then we look up at the density and relative density of different species and their dominance based on all of these samples which were collected, and determine the frequency and relative frequency of each species and assign an importance value to them. And then, so these are used when the average number of individual species to determine the average number of individual species per unit area, and when your site is predominantly large. And so we can also look up at the plant dispersion over an area within a community, and we can determine the relative density, the relative dominance, and the relative frequency of different species. So in sample plot methods, we just take samples from a plot of land randomly, and then determine the occurrence of a species. Then we have the transect and line intercept method. So we consider a line or a transect, and then we determine the ratio of total amount of species which are found on that line, and then we divide it by the total length of the line to get the percentage of the cover of the species. So we use this to determine the cover of the species and the dominance of the species. So if you have more than two species which are falling on the line, uh, we can determine the dominance of the species by whichever species is occurring more on that line. So, for example, in this particular case, we consider a 10-unit length of the line, and then we have two different species, which is this grass species and this other fourth grass species. So on this 10 scale unit, on this 10 scale line, we measure the grass species. So we have 1 unit of this grass species here. Then we have 1.7 unit, that is this grass unit uh, on the this line. Then we have another zero point 0.6 grass unit on this line and another zero point 0.8 on this line. So we add all of these values and then we divide it by the total length of the line to get the cover of the grass. So we have a total of 4.1 by 10. So approximately 41% of the transect is being covered by the uh, grass. Similarly, if we have to calculate it for foregrass, we would have to add zero point 0.9 plus 1.3, again divided by 10. So we have uh, 2.2 by 10, that is 22% of the transect of the line intercept is being covered by foregrass. So we can say that the cover grass is more dominant than the foregrass on this particular transect. So we determine both the cover and the relative dominance of the species. Similarly, you can have multiple lines on the site to measure the cover and the relative dominance of the different species on site. And then we have plotless sampling method. So we do not divide the site into different plots. We can use things like mean plot. We can measure the distance of the different plants from a sampling point. So this is the mean point, and then we measure the plant distance, and we can also calculate the mean area per plant. So we can look up at mean point plant, the mean area per plant, the density and relative density of the plant species, their dominance and relative dominance, and their importance value. Again, based on the distances measured and the area of the canopy which it covers. And then another method is the species list method, where we list all of the different species which we observed in the different communities, in the different animal groups, and identify all of these species which were present on site. And then we also have the count index methods or the roadside and aerial count methods. So we look up at the aerial photography, or directly count the number of species which we can see. So we can get the observation of animals by driving them past trained observers, and we can count all animals passing the fixed point within some stated interval of time. Then you can either do a direct count of the species, or you can also for certain birds and bird species, we also look up at their count call, or the amount of time they produce their calling sound. So we count the number of call sound as well in the count in this method. And then for fauna, we also have this removal method. So if you have a number of species, so you can capture them and then keep capturing them to determine the population size. So this is you capture them and you remove them. So these are the number of species captured, and it gives you a fair idea of the population size at the site. And then we also have the market capture method. So this is again the capture, release, recapture method. So you originally capture the number of species, and then you recapture a number of these marked animals. So you capture animals in the first instance, and then you replace them, and then after certain number during the census based on the population. So this gives you an idea of the population size estimate of your of the species which was tagged and recaptured and released. And then we also have a few mathematical and statistical models, which are minimum critical areas, viable populations, ecotoxicology, critical loads, hydrological processes, and uh, yes. And then we also test the significance of impact. So you can look up at whether there's a large changes in environmental conditions. So you can put a yes or no, and then you can describe the nature of the effects and the reasons or the actions which are causing these effects. If you answer them yes, and then you can again keep going through them. Will this effect extend over a larger area? Whether it will have any potential for transfrontier impact? How many people will be affected? How many receptors of other types will be affected? So it can be for flora, fauna, businesses, facilities, and other things. Whether any valuable or scarce features or resources will be affected, whether there's a risk of environmental standards being breached, whether there's a risk of protected sites, area features to be affected, what is the probability of this event occurring, how long will the effect continue, whether it's temporary or permanent, whether it is continuous or intermittent, or which occurs at a certain interval of time, whether it's frequent or more rare, whether it's reversible or irreversible, whether it can be avoided or reduced or repaired. So these are things which you need to assess the significance of your impacts with and give list the possible actions and natures of the effects. So this was what was covered in lecture 39. And we also looked up at the receptor sensitivity, that is, the ability of a species or habitat to accept these changes in the environment and the resilience to any changes which may occur. Moving on to lecture 40, we had the EIA methods on ecosystem services, part one. So we looked up at the ecosystem services, which are basically the benefits that people obtain from ecosystem. And these can be in terms of provisioning services, that is the direct output from the ecosystem, like food, medicine, timber, fiber, bioenergy, and things like that. And then we have regulating services like water filtration, waste decomposition, climate regulation, crop pollination, regulation of some human diseases. So these are activities or services which helps the ecosystem and regulates the functioning of the ecosystem. And then we have like supporting services like nutrient cycling, photosynthesis, soil formation, which supports the functioning of the ecosystem and maintains the well-being of the ecosystem. And then we also have some certain cultural services which are basically enriching recreational, aesthetic, and spiritual value. So these are the types of ecosystem services which we get from the ecosystem. And then we looked up at the different definitions and concepts. So we looked up at natural capital, which was the stock of living and non-living environmental resources potentially available to generate value. So we looked up at stocks as natural capital, the flows as services, and the value as benefit to businesses and to society, and direct benefit to well-being, for example, livestock farming, and these are easy to identify. And different intermittent services, which are indirect support providing services, and these contribute indirectly to our well-being by supporting other activities like hay production for supporting livestock production. So livestock feed on hay, and then they give us services like milk and milk products. So these are indirect services, and then but these are difficult to identify. Just one second. And then We also looked up at the evaluation of ecosystem services. So these are preference evaluation methods, or these are payments for ecosystem services, or PES. So these are fees for the user or polluter pay. So these are two different methods of evaluating, giving a valuation to ecosystem services. So fees for users, basically when the user pays the cost value of the services which it gets from the ecosystem. So these are implemented in US, Costa Rica, Nicaragua in, for example, in biodiversity conservation, and then watershed protection in South Africa and Mexico. Whereas polluter pays when the entity or the community which is polluting the environment pays the cost value of the damage it has caused to the environment. So, for example, China and UK have policies which ask the polluter to pay if it is causing things like carbon sequestration and other polluting activities. So the polluter in this case pays. So there's a mechanism by which ecosystem services are assigned a cost value, and then either the user or the polluter pays in the two different models which we saw. And then we also looked up at key interrelationships between ecosystem and the ecosystem service supply, use, demand, and benefit system. So we looked up at ecosystem service demand and use. So ecosystem service demand is the level or amount of ecosystem services which is desired by beneficiaries or the users to fulfill their requirement. And if the demand is realized or met, it equates to use. So demand and use, and then ecosystem service use is the level of particular ecosystem service actually consumed or enjoyed by the beneficiaries. And the use can be consumative or it can be a non-consumative type. So it can be like for recreational value, or it can be a direct product like milk and things. So that is a use of the ecosystem service. And so demand is basically what the users need or the beneficiaries need in order to meet all of their requirements, whereas use is the total ecosystem service being consumed. Use shed is when is the area people use for getting a particular ecosystem service, and ecosystem service supply is the maximum amount of service that can be drawn from the ecosystem without damaging its future productive capacity. And this can also be called as the maximum sustainable yield. So this is the maximum amount of service that the ecosystem can provide without it disrupting its production capability for the future. And then we also looked up at the we also looked up at that supply depends mainly on the ecosystem. So the type determines which services are provided. Condition or health determines the capacity of the ecosystem to supply them. And these are affected by the way resources are managed. We also looked about the consideration of the geographic extent of an ecosystem for the assessment of the capacity of ecosystem to supply services. So this is the geographic extent of an ecosystem, the biodiversity, structure, process, accessible supply, the barriers to use the supply. And so this was all which was covered in lecture 40. So if you have any questions, you can either unmute yourself and ask them, or you can put them in the chat box, or we can take them after the Q&A session as well. Okay, so these are questions based on the previous one of the NPTEL course of environmental impact assessment. So you can put your answers in the chat box, and I will moderate it. Okay. So you can just unmute yourself and answer the questions if you have. I'm unable to access the chat box at the moment. Okay. So the first question is, what is the acronym of NDC in relation to climate change policy framework? So is it national development contributions? Is it naturally determined contributions? Is it nationally determined contributions, or is it nationally democratic contributions? Okay, so the correct answer is C, that is it, nationally determined contributions. So these are basically the contributions which the different signatories to the Paris Agreement have assigned themselves as long-term goals to reduce the national emissions and to adapt to the impacts of climate change. Okay, so NDCs are national contributions. Okay, so moving on to question two, state true or false. Scoping in and scoping out with respect to climate change in AIA process mostly depends on nation to nation based on their legislative provision. Is the statement true or false? Okay, so the statement is true. That is different countries have their own scoping mechanisms with respect to climate change, and there is no uniformity in the climate change scoping process in EIA for the different species. So the statement is true, that is the scoping in and scoping out with respect to climate change in the EIA process depends mostly on the nation to nation based on their legislative provisions. Okay. So moving on to question three, select the following issues to consider in scoping for climate change adaptation. A, nature of the project, its location and resilience to climate change. B, climate related parameters likely to influence the project. C, anticipated changes to those climatic parameters over the life of the project. And D, all of the above. So you need to identify all of the issues or whichever of these issues apply to consider in scoping for climate change adaptation. We covered them in our highlight section as well. Okay, so the correct answer is D, that is all of the above. So you need to consider the nature of the project, its location, and the resilience to climate change. You need to consider the climate-related parameters which are likely to influence the project. You also need to look up at the anticipated changes to these climatic parameters over the life of the project, among the other different issues which you need to consider in scoping for climate change adaptation. So D, all of the above was the correct answer. Okay, moving on to question four. Which of the following information are considered for baseline studies for climate change adaptation? So A, historic or past climate conditions. B, current conditions at the time of assessment. C, future climate conditions, medium and long term. Or D, all of the above. So you need to identify what information you need to consider while determining the baseline study for climate change adaptation. That is, how are you going to adapt to the effects of climate, the effects of the changing climate? What information is required for consideration? Okay. The correct answer is D, all of the above. So you need to have the understanding of the past climatic conditions, the current conditions at the time of environmental impact assessment, and you also need to have future projections and future climatic conditions, especially for the medium, which is 10 to 30 years, and for the longer term, which is 50 years, or the lifeline of the project. So all of these information needs to be considered for baseline studies for climate change adaptation. Okay, moving on to question 5. I match the following terms of Group A with their description in Group B. So in Group A, we have terms like ecology, ecosystem, habitat, and biotype. And in Group B, we have their description or definition. So you need to match Group A with Group B. So the correct answer is B, that is ecology is the study of ecosystems, habitats, communities, and species, whereas ecosystem is the self-sustaining functional system consisting of physical, chemical, and biological attributes, whereas habitat is the condition needed to support a species or community of species in a particular location, and biotype is the environment typically supporting a specific recognizable community. So P matches with 3, Q matches with 1, R matches with 4, and S matches with 2. So B is the correct answer. So these are basically definitions. So again, definitions are important from an examination point of view as well as for your understanding. So please make sure that you understand what the different terms relating to EIA and its components mean. Okay, so the correct answer is C. That is, stability is the state in which changes over time are within normal bounds of variation, and it's the ability of an ecosystem to resist environmental change. Whereas fragility or sensitivity is the ecosystem's susceptibility or weakness to environmental pressures. Resilience or recoverability is the ability of an ecosystem to absorb disturbances without crossing a threshold to a different or usually degraded state. And recreatability is the potential for re-establishing an ecosystem of richness and complexity similar to the ecosystem that has been destroyed. So P matches with 2, Q matches with 4, and R matches with 1. S matches with 3. So C is the correct answer. Moving on to question 7. Uh, what do you determine in the scoping stage for EIA method of ecology? Question 7, what do you determine the scoping stage for EIA method of ecology? So we have A, study area, B, survey methodologies and assessment methodologies, C, key ecological issues to address, and D, all of the above. Okay, so the correct answer is D, that is all of the above. So, so during the scoping stage, we determine the study area or so during the scoping stage, we determine the study area or the impact area or subject affected area, the survey methodologies, the assessment methodologies, and their level of significance, and the key ecological issues addressed. So the all of the above was the correct answer. Okay, moving on to question 8. State true or false. Valued ecosystem components or VECs are the species, habitat, or sites that qualify in terms of their ecological or conservation value or socioeconomic value. Is this statement true or false? Okay, this is again based on the definition of valued ecosystem components. And this is the correct definition. That is, these are species, habitats, or sites that qualify in terms of ecological or conservation value or other attributes like their socioeconomic value. So the statement was true. Moving on to question 9, we have which of the following are the simple techniques used for ecological survey? That is, A is ecologist field walking and visual assessment, B is recording, C is thematic mapping, and D is all of the above. Okay, so the correct answer is D. That is, simple techniques include ecologist field walking the site, the visual assessment on the site, the recording of site, the thematic mapping. So all of these options are correct. So D, all of the above is the correct answer. Okay, moving on to question 10. Habitats that support a community which contains a large proportion of non-native or introduced fauna and flora, or where human activities have modified the area's primary ecological function is called. This is again based on the definition of a particular type of habitat. So whether is it A, natural habitat, B, modified habitat, or C, critical habitat, or D, none of the above. Okay, so the correct answer is B, modified habitat. So modified habitat is the habitat that supports a community of which contains a large proportion of non-native or introduced fauna and flora. And these are basically due to human activities which have modified the area's primary ecological function. Whereas natural habitat is the habitat which supports a community of native origin flora and fauna, and it has the primary ecological function uh, of the habitat has not been modified because of human activity. Whereas critical habitat is the habitat which contains a community of endangered or endemic species, or which is essential from an ecological point of view or from an evolution point of view. So those are critical habitats which needs to be preserved. So the correct answer was B, that is modified habitat. Okay, moving on to question 11. Identify the method as shown in the image, which is used for impact modeling of flora. So we have the image uh, being shown in the presentation, and we need to map the what type of impact modeling is being used. So we have A, sample plot methods, B, transact and line intercept methods, D, C, plotless sampling methods, and D, speciesless methods. So the correct answer is B, that is, this is a transact and line intercept method. So you basically have a line or a transact, and the unit length of the line is being taken as 10 here, and then you identify the different species which are found on the line, and you measure them and their cover. So you count the total amount of their cover. That is, for grass, we have 1.7, zero point 0.6 at this stage, and zero point 0.8 at this point. So we count all of it and divide it by the total unit of the line being considered, and then you get the cover of this species. And similarly, you can do it for all the different species. So you use transit and line intercept methods to get the cover and relative dominance of these species. So the correct answer was B, transects and line intercept method. Okay, moving on to question 12. Match the following methods for impact modeling of biological environment given in group A with their application given. So in group A, we have the different methods for impact modeling of fauna, and in group B, we have their applications to particular cases and their observations which you get out of them. So you need to match group A with group B. Okay, so the correct answer is D. That is, speciesless method is used for listing all the animal communities which can be observed directly on the site. Whereas count index methods, roadside and aerial count methods are used for observation of animals by driving them past trained observers so that they can count them, or doing it at the counting them at a particular interval of time. Is count in this method, and then removal methods are applied to the number of species being captured. So R matches with 1. And plotless sampling methods is used for mean point plant distance and mean area per plant uh, for plant for flora. So the correct answer is D, that is P matches with 4, Q matches with 3, R matches with 1, and then matches with 2. So moving on to question 13, state true or false. Market capture method is one of the methods for impact modeling of fauna. It involves capturing a portion of the population and at some later date sampling the ratio of marked to total animals caught in the population. Is this statement true or false? Okay, so the correct answer is A, that is true. So market capture method works on capturing the is used for impact modeling of fauna or animals, and then you capture the portion of this population, and then you mark them, and at some later date you again sample the same population to determine the ratio of marked animals to the total animals caught in the population to estimate the population size. Okay, so A, the statement was true. Moving on to question 14, match the following terms of ecosystem services in Group A with their description given in Group B. So we have ecosystem services being listed on Group A, and Group B have their definitions. So you need to match Group A with Group B. Okay, so the correct answer is B, that is natural capital is the stock of living and non-living environmental resources, potential available to generate value. Whereas final services are direct benefits to human well-being. Intermediate services contribute indirectly to human well-being by supporting other services, and beneficiaries are people or ecosystem components who derive benefit from an ecosystem service. So P matches with 3, Q matches with 1, R matches with 4, and S matches with 2. So B was the correct answer. Moving on to question 15, match the following terms of ecosystem services in Group A with their description given in Group B. So again, we have terms from the ecosystem services and their definitions in Group B. So you need to match Group A with Group B. So the correct answer is A, that is shed is the area people use for getting a particular ecosystem service. Ecosystem service demand is the level of amount of ecosystem service desired by the beneficiaries to fulfill their requirement, whereas ecosystem service use is the level of a particular ecosystem service actually consumed or enjoyed by beneficiaries, and this use can be consummative or non-consummative type. The ecosystem service supply is the maximum amount of service that can be drawn from an ecosystem without damaging its future productive capacity. So P matches with 2, Q matches with 3, R matches with 4, and S matches with 1 is the correct answer. So A is the correct answer. Okay, moving on. So this was all from the previous one of the NPTEL course. We will now look at the week 8 assignment because the deadline for the same has passed. So we will look at the answers for week 8 assignment as well. Okay, so we looked up at this in our previous one practice questions as well. So state true or false, scoping in and scoping out with respect to climate change in the AIA process mainly depends on the nation to nation based on the legislative process. So the statement is true. Okay, moving on to question 2. Select the COP meeting by which India aims to reduce the carbon intensity of its economy by less than 45% until 2030. So which of the following congregation of parties is the meeting uh, did India declare that it will reduce its carbon intensity by less than 45%? This is also the COP in which India adopted Panchamrit, and this is one of the five world strategy. Also, India aims to be net zero by 2070 as declared by the Prime Minister Narendra Modi. Okay, so the correct answer is D, that is COP26. Uh, so in COP26, the PM declared that India is going to reduce its carbon intensity of its economy by less than 45% by 2030. So D, COP26 was the correct answer. Moving on to question 3, what is the full form of UNFCCC? Is it A, United Nations Framework Convention on Climate Change, or B, United Nations Framework Conference on Climate Change, or C, United Nations Framework Classification on Climate Change, or D, United Nations Framework Committee on Climate Change? So only the first C is the differentiating factor. Okay, so the correct answer is A, that is, it's the United Nations Framework Convention on Climate Change. Moving on to question 4, match the terms given in Group A with their description in Group B according to the vulnerability and sensitivity of the sector classification. So is it B, high vulnerability, moderate vulnerability, or low vulnerability? And in B, you have the sensitivity classification. So you need to match Group A with Group B. Okay, so the correct answer is B, that is high vulnerabilities when the receptor is directly dependent on prevailing climatic factors and reliant on their continuation or limited variability. Whereas moderate vulnerabilities when the receptor is dependent on some climatic factors but unable to tolerate a range of conditions. And low vulnerabilities when climatic factors have little influence on receptors. So B, uh, P matches with 2, Q matches with 3, and R matches with 1 is the correct answer. Okay, moving on to question 5. We again looked up at these in the previous one questions as well. So you need to match the ecosystem resilience attributes given in group A with their elaboration given in group B. So we have stability as the state in which changes over time are within normal bounds of variation and the ability of an ecosystem to resist environmental change. The fragility is the ecosystem susceptibility or weakness to environmental pressures. Resilience or recoverability is the ability of an ecosystem to absorb disturbance without crossing a threshold to a different, usually degraded state. And recreability is the potential of re-establishing an ecosystem of richness and complexity, similar to the ecosystem that has been destroyed. So C was the correct answer. Okay, moving on to question 6. Match the following terms of group A with their description in group B. So we looked at this in the practice questions as well. So we have terms relating to ecosystem, biotype, ecology, habitat, and their definitions in group. So the answer given in the assignment solutions is B, but the correct answer is C. That is, ecosystem is the self-sustaining functional system consisting of physical, chemical, and biological attributes, whereas habitat is the condition we need to support a species or community of species in a particular location. Biotype is the environment typically supporting a specific recognizable community. And ecology is the study of ecosystem, habitats, communities, and species. So P matches with 4, Q matches with 3, R matches with 1, and S matches with 2. So C is the correct answer instead of P, and we will communicate this to the NPTEL team as well. So C is the correct answer. Moving on to question 7, state true or false. According to the IAIA, there are 4 key questions for scoping with respect to impact on climate and climate change. Is the statement true or false? Okay, so the statement is true. There are 4 key questions for scoping to determine whether and to what extent climate change is impacting the uh, has an impact. So you need to look about the proposal, that the proposal will directly or indirectly increase or decrease greenhouse gas emissions. The second question is the proposal beneficial or adversely affected by and vulnerable to climate change, either directly or indirectly? Question three is climate change affecting other aspects of the environment that are potentially affected by the impacts of the proposal? And question four is an objective of the proposal is to use impact assessment to identify alternatives and measures to mitigate and or to adapt climate change. So these are the four questions for scoping as according to the IAIA. So the statement was true. Moving on to question eight, which among the below given is the approach for baseline studies? So we have A, listing approach, B, snapshot approach, C, dynamic baseline, and D, all of the above. Okay, so the correct answer is D, all of the above. All of these are approaches for baseline studies. That is listing approach, snapshot approach, and dynamic baseline. Moving on to question nine, we have DAFOR is used for species abundant measures. What does DAFOR stand for? So this is one of for measuring the species abundance, uh, similar to cover, frequency, and the count of species. So each of the initials of the abbreviation DAFOR stands for a category of species based on the abundance of the species present on the site or the project site. So the correct answer is A, that is D stands for dominant species, A stands for abundant species, F stands for frequent species, O stands for occasional species, and R stands for rare species. Okay, so the correct answer was A. Moving on, what is plotless sampling? So is it A, sampling conducted within defined plots, B, sampling is not conducted within defined plots, C, is conducted using quadrants, and D, sampling is conducted using circles? This is a fairly straightforward question where the answer is within the question itself. So plotless sampling is when the sampling is not conducted within defined areas. That is, it is not being defined into plots or subplots. So the correct answer was B, that is sampling is not conducted within the defined areas. Moving on to question 11, say true or question 12. Some species have very limited dispersal ability, and such low mobility species are unrestricted to remaining habitat patches or too unlikely to recolonize isolated habitat patches. Is the statement true or false? So we looked up at these type of species when we talked about habitat fragmentation, where the habitat is being divided into a number of different habitats by human activities like construction of roads or railway lines or highways and things like that. So the habitat is being fragmented into two or more parts, and this leads to creation of more edges and the ecosystem being reduced to a smaller area. So species which are so there are two types of species in these habitats. There are species which adapt to these changes and are not restricted to the remaining habitat patches. Whereas there are species which have very limited dispersal ability and low mobility, and these are and they are restricted to these remaining habitat patches, and they are they are unlikely to recolonize in the isolated habitat patches. The statement is false because statement one is incorrect. That is, low mobility species are restricted in the remaining habitat patches itself. So the statement is false. Okay, moving on to question 13. What is the full form of PES? Is it A, payment for ecosystem services, B, placement of ecosystem services, C, position of ecosystem services, and D, or depollutants of ecosystem services? Okay, we looked up at this in the valuation services. Okay, so the correct answer is A, payments of ecosystem services, where we have two models, that is the fees is being paid by the user or the polluter pays, as implemented in different countries for different uh, control. So the PES stands for Payment for Ecosystem Services. Okay, moving on to question 14, state true or false. The area people need access to for an ecosystem service to be sustainable in terms of the level of benefit they need or depend on is called a use shed. Is the statement true or false? So this is again based on the definition of a use shed. We looked up at the definition of use shed in lecture 40. So the correct answer is false. Use shed is basically the area people use for getting a particular ecosystem service. And this is not the area which people need to access for an ecosystem service to be sustainable in terms of the benefit they need or depend on. It's just the area that they use for getting a particular ecosystem service. So the statement is false. So again, statements and terms and their definitions are important. And their understanding of these statement is not the correct definition of the term. So the statement was false. Okay, so moving on to the last question for assignment 8. We have, what is the survey technique for large mammals? Is it A, radio tracking, B, speed tracking, C, snap traps, D, mesh tubes? So we looked up at survey techniques for animals and for mammals. Mammals include bats, small mammals, and large mammals. So for large mammals, we use radio tracking or direct observation tracking. So A, radio tracking was the correct answer. Okay, moving on. So this was the assignment solutions. I will post the video link as well as these presentation slides on the Google document. You can access the presentations as well as the YouTube videos from the problem solving tab on the left hand side of the uh, course, and you will definitely have links to all of the video content as well as the lecture files for the different weeks content. And if you have any queries, you can post them in the discussion forums. We go through the discussion forums when we create these slides for each week to answer your queries. Uh, okay, if you have any queries, you can unmute yourself and ask now, or you can post them in the discussion forums later as well. Okay, if there are no queries, thank you so much for attending the week 8 problem solving course, problem solving session for the NPTEL certification course on environmental impact assessment. Please feel free to give feedback on the survey form which has been circulated by the NPTEL team for each week. And please let us know how we can improve ourselves. And thank you so much for attending this session. Again, the video for this recording will be put on YouTube and you can access it again. Okay. Thank you so much.